Hi, Stuart again. More 12 factor. Today, number 1, CodeBase. One CodeBase, tracked and revision control, many deploys is the rubric. And we're going to talk about some CodeBase best practices today. Should it be in source control? Handy guide. If you can't put it in a file, or it's a secret, or it's a binary, see next slide. But if it's anything else, it should definitely be versioned in source control. Anything that has to do with your software development process, anything that delivers business value should be in source control. So what about binaries? Yeah, that's traditionally been a problem until the invention of binary repositories, like my favorite, JFrog Artifactory or Nexus repo or GitHub repos or Azure repos or Amazon repos. Everybody's got a nice binary repo, and it typically responds to all of the favorite protocols from all of your favorite stacks. So whether you're a .NET developer using NuGet, a JavaScript developer using NPM, you're using Composer with, for example, PHP or Python, you will find that there is a nice place to put your binaries and packages. And if you're using something like Go or Rust, they have that built into the stack because it's that important. And if you find that you have a stack that doesn't have any kind of package management or binary management, switch stacks. Seriously. Linus Torvalds is a genius. He invented Git. Lots of people have made it better. Every big enterprise code shop you have any respect for at all uses Git. There's no bake-off. The bake-off is done. It's Git. Virtues of Git are the same virtues of a lot of different source control systems all in one place. It's blazingly fast. It doesn't suffer attenuation problems when the repository gets big. It supports a rich branching and merging language. It's free and open source. It allows you to stage things, etc., etc. And you can go read all about Git, if you don't already know about it, on the Git SCM site. So it's worth visiting a best practice or two. Here's the best practice for developers who have at their control a Git of their very own. And why wouldn't you? It's free. Generally, what you do is make a feature branch, and we'll talk about branches in a sec. Code a little, test a little, do a commit, do a push to your feature branch up in the sky, repeat, and keep doing it until you're ready to put in a pull request. And a pull request is, hey, look at my code, and if you like it, you can join the main code that laughs and plays with all the other code. And if you hate it, then my code will never make that code unhappy. Code a little, test a little, commit, push, repeat. So in Git, we talk about your local workspace that's on your hard drive, in my case on my laptop, and an origin. Now, technically an origin can be anywhere, but these days it's probably in some sort of a code hub. So Bitbucket, my personal favorite, GitHub, ADO, the good folks at Atlassian who make Jira have a very nice Git. And so it's centrally managed, and the advantage to that is you get it backed up and it's highly available and it has disaster recovery and it's lovely. But it turns out that you don't really need an origin if you're doing something open source. Although if you were doing something open source and you had the desire to share it with others, you'd probably put it on GitHub, which is where all my open source is. So generally what you do is you go up to the origin and you pull down the latest version of the files in the developer branch, and you create a topic branch on your local area. Sometimes it's called a feature branch, depending on what author you're reading. Topic branch, feature branch are morally equivalent. You tell the origin that you've made a feature branch, and you code and push things from, you code on 2 and you push to 3, so your code is safe over there if your laptop gets run over by a rhinoceros. And then when your code is ready to join the rest of the world, you do a pull request. So here's the pull request test. If you are the reviewer of a pull request, then read the code. And is the code okay? Then yes, complete the pull request. And the feature branch typically is deleted. If not, put comments about why you don't like it and reject the pull request. And they can keep their feature branch, go back and fix what you don't like, and do another pull request. And they can keep doing it until you hit the green. Peer review checklist, right? So you're looking at a pull request. Does it meet the requirements? Does it conform to the shop standards? Is it well documented? Is it a bite-sized chunk of work with one intention in mind? One of the things that you want to get people out of the habit of doing is working for 3 months and then doing a pull request. If you're a reviewer, reviewing Miller's number, 7 plus and minus 2 files, is a lot easier than trying to review 70 files, right? So we want to encourage developers to do continuous development with lots of pull requests. And we want our code to be clean and solid. We want to not embroil or embellish our code in things we absolutely don't positively need. And if your shop wants to associate metadata like your story number or your bug number with it, and that's part of your shop standard, then that should be part of your peer review as well. Which brings us to branches. Simple, is better than complicated. One of the things that we see when people adopt Git is they fundamentally don't understand how it works. And if you want to understand how it works, you can go to gitscm.com, and they've got some nice tutorials. I have a YouTube video on it. But the magic of Git is its internal workings. And those internal workings mean that you don't actually need to create that many branches. So typically, you have a master branch. By the way, I should update this slide. It's no longer PC. I left master because that's what it's called in the documentation. But almost everybody immediately renames this branch to main, and you can Google how to do that. So going forward in my presentations, this branch will be called the main branch, off of which you fork the develop branch. And the develop branch is where business value gets added by developers creating feature branches and then having them be pull requested back into develop. At intervals, we then merge into master, and it's generally in celebration of a release. Occasionally, we need to do a production hotfix, and those go into a hotfix branch off of the main branch and are pulled back into master and are reverse engineered, reverse merged back into develop so that our hotfixes are there. But notice this is really, really simple. At any one time, you've got 2 main branches, and you've got as many feature branches as you've got concurrent features. And when you're done implementing the feature and it's gone into develop, you typically delete the feature branch. Simple is, and again, a lot of people coming from a lot of those other less desirable source control systems will say, well, no, we need a release branch, and we need a this branch and a that branch and a train branch and a plain branch and goodness only knows what branch. But no, indeed, in Git, you do not need any of those things. For those of you who think you do, please go see how Git works and then cogitate on the following thought. Tags are your friends. So you can memorialize a release by tagging a particular commit in source control. You can memorialize that something was deployed to dev, QA, staging, UAT, production, demo, whatever, by putting a tag on your commits. And tags allow you to recreate the exact state of the code at that moment in time in your tag. And so that's a very good thing. And so you don't need a branch to memorialize those things anymore. So don't do it. Semantic versioning. No if, buts, ands, or ors. Every single enterprise shop for which you have any respect adopted semantic versioning a long time ago. What does that mean? It means that if we have a 3-part version number, major, minor, and patch, patch is just simply saying if the patch number goes from 10 to 11, that means I had some minor bug fixes, etc. If the minor version goes up by 1, it means you added some extra features. But they're non-breaking. Like the old stuff will still work, but there's some new stuff you could use if you want. And what you're saying when you increment the major branch is, we broke all your toys, right? Breaking changes should get new major versions, and you should make sure that you're offering the old one for a while alongside your new one, because not everyone is going to be able to drop everything and go from your old one to your new one. So your old one should still work, and your new one should be available for folks that are ready to adopt it. Seriously, don't break people's stuff. And if you want to learn more about that, go to semver.org, and you can also Google Code Evergreen in your favorite Bing box, and it will give you lots of scholarly articles on that.